All right, let's go over our assignment on the computer printouts and interpreting the standard deviation of slope residuals and then writing those that least squares regression line given those summary statistics instead of individual pieces of data. Okay, so here we have our first problem. So one of the first things that you have to do in a problem such as this is identify which is the variable that is the x and which is the variable that is the y. So as we read through, so what happened was as I read through, I was like, oh, I'm recognizing these things they're giving me are these mean points, and then the standard deviations and the correlation coefficient. So I think that's that other way I have to do to get the LSRL. Then I say, hey, which is the x variable, which is the y variable? So that's what I did here. So since it is asking me to predict the number of fish species present, if there's an average pH at 7.6, then that to me, of course, was an indication that another indication that I want those number of fish species there are to be my y variable because I'm going to be predicting that. So therefore, my pH is my x. This is the x bar. And again, you would write it with the x and the bar over it, but I'm not able to do that with the program that I have. So of course, you would want to do this for your x bar and this for your y bar. Okay. So there we go. Our standard deviations of the x and the y and our correlation. So slope first. Remember our slope is our standard deviation of the y over the standard deviation of the x, the variability of the y over variability x times the correlation coefficient. So that slope was 1.98. Then I'm going to use that equation, where I have my y bar equals slope times x bar plus the y-intercept, okay? And then I just plugged in the three things that I have and solve for the y-intercept. So therefore my prediction equation was predicted number of fish species equals 1.98 times the pH level minus 7.3. Again, y-intercept wouldn't make sense because if I was interpreting this, the pH of 0 would have negative 7.3 predicted fish species in there. And then they asked me to predict with an average pH of 7.6. So there I just plugged in my 7.6 and I got 7.75. So that's predicted. So again, I can say predicted number of species, okay, is this amount that's not realistic. Okay, next. It was not necessarily apparent naturally which is the X and which is the Y. So therefore, since it says predict what her score would be on the calculus final, so that indicates to me that I wanted to use calculus as that y variable. So then I went up there and so I, labeled my x and y values, and then I came up and I identified the x bar, y bar, s of x, s of y, and the correlation. Went through. Slope is r times the s of y, variation in y over variation in x. So there's my slope of 0.6. Pooh, I see I did something wrong here. Look, right here. That is not correct. I'm supposed to put 0.61 right there. My slope was 0.61. So I may need to recalculate that. Y-intercept, that's going to change all my numbers. Okay, so anyway, so I would need to do that 0.61 times the 175 and then do my 80 minus that, which was a 106 something. Okay, I've already lost it. All right, so I'm flustered that I don't have that right answer there. Pooh. So again, 0.61 times 175, 106.75. So I'm going to do 80 minus 106.75, and there we have the negative. So this should be negative 26.75. So see here, that's wrong. That's supposed to be negative 26.75, negative 26.75. So then that's going to be different. Okay. All right. So you can go in there and you can fix that. So it seems like this should be minus 26.75. And then I'm going to go in there. I'm just going to leave that for now. Go in there and calculate, and then you would come up with what that is. So minus 2675. Go plug that in and see what you get. Okay, now we have this data set. Well, so this is interesting, okay? Here we have a data set. So this is what actually happened. Okay, so this is the actual values. Now we have a prediction line with this equation right here, and it has the residual of x equals 73. So see, look here, I'm going to start identifying my items over here, my x, my actual y, my predicted y, and then I have that residual, or finding the residual. So here we go. X is the 73. Actual y is 7.9. That's what this point is telling me. X was 73. 7.9 was the y. So I'm going to predict the y. That's the use this equation. So I'm going to do predicted y. So in my x, I plug in 73 right here, and I get 7.96. So with my residual RAP, RAP, my residual is actual y minus predicted y. So that's 7.9 minus 7.96. So there's my residual, negative 0.06. All right, next, moving on here, we have computer printout. So we're going to identify this. Look, see, this is gone here. So we know we're getting those coefficients right there from the slope and the y-intercept here. This constant is the y-intercept. So there's that. Is the slope. 0.11832 was the slope times the number of casino employees. So I guess I had to figure out what was x and what was y. Here's how I did that. Number of casino employees. So that right there is my X variable. Okay, so there's that. And then keeping in mind that this is the crime rate per 1,000 in the population. And this number of casinos employees is in the thousands. Okay, so keep those units in as we go along. So here we go. So state and interpret the correlation coefficient. And again, what should that say? That should say describe the relationship. Okay, our new way of doing that. For every increase in 1,000, oh wait. Why did I do the slope there? Look at what I did. State and interpret the correlation coefficient. What did I do? I stated and interpreted the slope. It didn't ask me to do that. So anyway, so with this, I would say there is what's our correlation coefficient? Or our R squared was 97.4. So our R value, so then our R should be the square root of at 0.974. 0.974. Woo! I got all these kinds of problems in there. Okay, so here we go. The square root of 0.974, square root, right there, 0.987. So that's 0.987. So there is a strong positive, because the slope is positive, strong positive linear relationship between whatever those two things are. Positive linear relationship between those things. Relationship between the things, da 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 da, and so on. How did I do that? Interpret the slope. There's that coefficient of determination of 97.4%. So about 97.4% of the variation in the y can be explained by the changes in the x. And look, I should have that here. About 97.4% of the variation in the crime rate can be explained by the varying number of casino employees. So lots of things here. The varying number of casino employees. Okay. Now we have state and interpret the standard deviation of the slope. So that's my song that we're going to do here, that standard deviation. See, this is interesting. This one has S standard deviation instead of SE coefficient. But here is that slope line. Okay, so that's the standard deviation of the slope. So if I come on down here, I'm going to say, if you sampled many times, I'd expect the slope you find of the relation between crime rate and number of casino employees will vary about this much on average. And I probably should have put some units in there, don't you think? So we're talking about, I don't really know exactly. Is this a percent crime rate per 1,000 employees? Um, I'm not sure. So I guess that's why I left it blank here when I did that. So I just go ahead and we'll just leave it that way since the units was kind of unclear. It's kind of difficult. All right, interpretation of the residual standard deviation of the residuals. Okay, so the average amount that the actual Y, so the average amount that the actual crime rate varies from the predicted crime rate is 0.1499, whatever that units is. All right, so predict the crime rate for this. So, we're using a prediction equation, okay? So I put that word predicted crime rate in there because my program, I didn't put the little hat on there. So there was your predicted crime rate. Writing the word is okay. So there was the equation. So there's the slope times the, notice this is 20,000 casino employees, and I put in 20, okay? And so that's 1.97. And here's this one here. So if we have 12,000 employees, so I put in 12. Okay. And this is the crime rate. So that's the actual, and its crime rate is 0.05 crimes below what is expected. That's interesting. The crime rate is 0.05 below what is expected. So guess what? That meant boom, it was telling you the residual is negative 0.05. Okay, so I didn't come right out and say residual. I said the crime rate is below what was expected. So there's that. So then what is the actual crime rate? How many crimes per 1,000 people occurred? So the residual is the actual Y minus predicted Y, that predicted Y was 1.02. So the actual crime rate was, I guess, 0.97 crimes per 1,000 people. Okay. All right. Now here's this next one. Here we have the 22,000 employees. So I'm going to take that and put that into my equation with 22. And look, here we go again. The crime rate is 0.63 crimes above what was expected. That's the residual. That told me the residual right there. So there we have that, and then we plug in residual equals actual Y, which we don't know, minus the predicted Y, which we calculated. And so therefore, then that actual crime rate was 2.84 crimes per 1,000 people. Is that how that was working? Okay, moving on. Now we have this AP free response question. So interesting is that you have a throwback here at the beginning to experimental design, Unit 1. Okay, throwback to that. So I went ahead and left that in there for you. Identify the treatments. That was the different concentrations of the garlic concentrations in the food granules. The experimental units, who are the subjects? They were the 40 European starlings. What response is being measured? So, how are you going to tell what happened? Well, we are measuring the number of food granules that the dog or that the birds consumed during that 2-hour period after they had been deprived of food. And so we were going to see if that made a difference in what they consumed. So here's our data. Okay. So then construct a graph of data that could be used to investigate the appropriateness of a linear regression model for analyzing the results. So I thought I needed to have a scatter plot where I have got this garlic concentration because that was a quantitative value, even though we kind of have these categories here. That was a quantity. And then the average number of food granules consumed. So here we go. Here is what I chose to do. And then you don't have to connect them like that, or even put this line right here through there. Okay. But whatever. The key is that you labeled correctly. Down here, we have percent of garlic concentration. Over here on the side, average number of food granules consumed. And then these dots were coming from the table here. Okay, with the X of 0, I'm at 58 food granules, and so on. 50% concentration, 20 food granules. And so we see this pattern. So based on that, do you think a linear model is appropriate? Explain. And so no, a linear model is not appropriate. There is a curved pattern in the data. That's all you had to say. But, again, if I was to make a residual plot, then I would have this pattern in the residual plot kind of like that. That was not required to get credit. All right, our next one, looky here, 2011. Here is what they gave you for your computer printout, okay, and your data. So the first thing they asked you to do was give the equation, the least squares regression line. Identify all the variables used. That means put this in context. So here, because this is right here, I know my wind velocity is my x variable here. Okay. And up there, I guess I was predicting the electricity produced. So here I have predicted electricity produced equals, here's the slope, 0.240 times the wind velocity plus the y-intercept of 0.137. Now I come on here, and how much more electricity would a windmill be expected to produce? So I'm getting the predicted amounts, okay? How much is predicted for 25 miles per hour versus 15 miles per hour of the wind velocity? So you could do it a couple of ways. You could say, okay, that's a difference of 10, and just plug in 10 right there for the wind velocity, okay, and do the equation once. I happen to do it twice. I plugged in 25 for the wind velocity and got that. I plugged in 15 for the wind velocity and got that, and then I subtracted those two to see what the difference is. Whichever way you did it, make sure that you showed how you did it and how you did that work. And look at this next one. What proportion of variation in the electricity can be explained by that linear relationship? The percent of variation that is found in the y, it can be explained by the changes in the x, or it can be explained by the model itself. That's the linear relationship with the wind velocity. So the key here was knowing what they were asking for was the coefficient of determination. So you just had to identify the r squared. Okay. All right. I think that was all for that assignment. Yep, that was it. Okie dokie. Sorry about a few of those wrong things, but it's good to notice that now, and I can fix that before class tomorrow.